Santa Rays. Today we will be talking about prime factorization and finding the prime factorization of numbers, representing it, being able to write it, and being able to find what each part is of prime factorization. So let's talk a little bit about factors. So we know from all of our years in school so far that factors are the parts that make up a multiplication problem. Well, we're going to talk about factor pairs. So factor pairs is going to play a really important role in representing prime factorization of numbers. So our factor pairs are a pair or two. So usually things that are pairs are in two. A pair, two factors that make up the product. Okay, so it makes up the number you're looking for. Well, let's talk about what this could mean. So if we have factor pairs, let's give you an example. If we are looking for the numbers that make up 10, 10 is made when you multiply 2 and 5. The 2 and the 5, those are factor pairs because they make up that 10 right there. So it's the pair that makes it up. 10 can also be made by the factor pair of 1 times 10. That also equals 10. Those right there, these are the factor pairs. So factor pairs. So let's do an example of factor pairs for the number 30. So let's say that I have the number 30. So let's do example A, and I have the number 30. For example, let's say that in a marching band, the brass section has 30 members in it. You can put the number 30 into many different rows. You could have those instrument players be in a row of 1 by 30. So your row could be one row of 30 instrument players. You could also have a row that is 2 by 15 players. You could also have a row that is 3 by 10 players. So you could put these people in these different rows. Another factor pair or another way to represent 30 is 5 by 6. So you could do 5 by 6. That is another factor pair. Another factor pair then would be 6 by 5, but that one is already listed. So you can put these all in the opposite way. So 30 by 1, 15 by 2, 10 by 3, and 6 by 5. If you've already used the numbers, don't reuse them. So we wouldn't do it again. You would either list it this way or that way. So we can even make a note out here. Only use the factors once. All right. So these are the possible arrangements that you could put people in to rows. Okay, so I want to know, how about let's do a try it really quick. That was a quick one. Let's do a try it. Please tell me the factor pairs for 18. So go ahead and hit pause right now and tell me, what are the factor pairs of 18? What factor pairs do we have for 18? So the factor pairs, hit pause so you don't hear me, our factor pairs for 18. 18 can be made by 1 and 18, 2 and 9, and 3 and 6. So our pairs are 1 and 18, 2 and 9, 3 and 6. Those are your factor pairs. It's like wearing a pair of socks, but numbers. Yeah. Okay. Let's go to our next idea. Okay, so our next idea that we're going to look at, it is called prime factorization. So our next word is called prime factorization. Okay, so prime factorization has a clue in it for what does it mean. The clue is in that first word of prime. So prime factorization takes a composite number and breaks it into all of its prime factors. So prime factorization takes a composite number and breaks it into prime factors. So we know that prime is like 1 and itself. And so what we'll do is take a composite number and we will break it down into prime factors. So like using factor pairs to break it down. We do this with factor pairs and a factor tree. So our next word that we're going to look at is called a factor tree. A factor tree is a way to organize all of the information. So a factor tree organizes factor pairs into prime factors. What in the world is she saying? All these words about factors. Just trust me on this, okay? I'm going to show you what a factor tree is, but know that it has prime factors and factor pairs. Okay, so here we go. Let me do an example with you right now, okay? So let's say that I have, let's do example B now. I have the number 60. 60 is the composite number. We are going to break 60 up into prime pairs or a prime factorization, okay? So the way that we can make 60 is you can do 2 times 30. A prime number is right here. It is the number 2. 2 is a prime number. I can't break this number up anymore because it's already 1 and itself. But 30 I can break up. So 30 I can make by doing 2 and 15. Again, I have another prime number in my tree. I have the number 2. 15. 15 can be made by 3 and 5. 3 is a prime number, and so is 5. I now have a factor tree. It's a way to organize my factors in my composite number. So when I find the factors, I just come over here now and I list them out. I had 2 times 2 times 3 times 5. I can use this problem right here to find the prime factorization, which is 2 squared times 3 times 5. And you know what? You can go back and you can try to solve this, and it will equal 60. So 2 times 2, that's 4. 4 times 3, that's 12. 12 times 5, that's 60. It's like you've just created the order of operations, but in reverse. So prime factorization is taking the composite number and breaking it into its prime factors with using a factor tree. Whew, that's a lot of factors. Okay, let's do another one, but I need to turn my page. So go ahead and hit pause right now if you're not able, or if you didn't get this written down before I turn my page. Okay, let's do example C. So example C, we're going to look again at another factor tree, or writing the prime factorization of a number. So let's look at the number 48. Okay, so 48, we can start this just with 2 again, just by breaking it down by 2. Well, I know that 2 times 24 makes 48. 2 again is already a prime number, so I don't need to do anything with 2. But 24, not prime. I know that 2 and 12 make 24. I also know that in order to make 12, I could do 3 and 4. Another way to break this down now even further is 2 and 2 to make 4. So the number 48 is a composite number. These are all the primes that we can pull out of 48. But wait, there's more. What if you knew off the top of your head that 48 could also be made by multiplying 3 and 16? I don't have to start with the 2 because I can start with the first factor that comes to mind. Well, I know then 16 is made by 2 and 8, and I know that 8 is made by 2 and 4, and 4 is made by 2 and 2, and oh my goodness, would you look at that? I have 1, 2, 3, 4, 1, 2, 3, 4, and a 3. So in order to make this, I have 2 to the 4th power. This one was 2 to the 4th power. Oops, times 3. And this one is also times 3. So when I look at all of these numbers, they give me the exact same prime factorization. So in order to make 48, in a prime factorization, I multiply 2 times 2 times 2 times 2 times 3, or I can condense it all down to 2 to the 4th power times 3. Again, same number, but there are many ways to arrive at your final answer. Okay, I would like for you to please do another try it. All right, let's do another try it. So your try it is the number 20. So the number 20. And let's do another one of the number 88. Okay, so go ahead and hit pause right now so you don't hear me solving those. And then we will go from there. All right, so we have 20 and 88. I know that 4 times 5 gives me 20. Well, 5 is already a prime, so I only need to worry about 4, which is 2 times 2. So 5, 2, and 2. So I would say 2 times 2 times 5, which is 2 squared times 5. That is my prime factorization. Okay, let's look at 88. Well, let's see here. I know that 8 times 11 gives me 88. And I know that 2 times 4 is 8. And I know that 2 times 2 gives me 4. So 11 is already prime. I have 2's here. So my prime factorization for this one is 2 times 2 times 2 times 4, which equals 2 to the third power. Nope, times 11. Man, I wrote that down wrong. No! Okay, there we go. Fixed it. Times 11. Do not do the 4 because the 4 wasn't circled. So 11 is your primes. Only primes go in the bottom. Okay, so let's look a little bit more at our essential question about writing the representation of prime factors. Okay, so how do we represent prime factorization of numbers? Well, you can represent the prime factors in a factor tree. You can represent them also in factor pairs. So you can pull out the factor pairs, and we can also write it with factor trees to help us get to the prime factorization. So go ahead and answer your essential question down below, and then give yourself a rating. How are you feeling about prime factors and prime factorization? 1, I need to make sure I have my hundreds chart with me so I can know what's prime and what's not prime. 2, I'm doing okay with this. I just need to make sure that I'm organizing my work. 3, I totally understand this. I've got primes, I've got composites, I know how to compare them, and I know how to write it as a final product. When you are done answering your essential question, you can go ahead and head on over to the Google Meet if you need some extra help, and I will give it to you. Or you can head on over to do your practice work. As always, Manta Rays, I hope you have an awesome day, and thank you for all of your hard work. See you next time.